In this example, we're going to simplify this expression and express our final answers with only positive powers. Here we'd like to explore one of the distributive properties of powers. And that is, if we have a fraction, we can distribute this outer power to both the numerator and the denominator. Doing this distribution, we get something that looks like this. Notice that I've taken the whole numerator and raised it to the power of -3. I've also taken the whole denominator and raised it to the power of -3. From here, we can distribute our -3 into the brackets because all of our terms are separated by a multiplication sign. So in the numerator, we would get something like 2 to the -3 times x to the -1 times -3 and y to the power of -3. Doing the same distribution process in the denominator, we're going to get x to the 2 times -3 and y to the -3 times -3. Now here's a little tip I have for you as you're working with negative powers. If we take our exponential expression that has a negative power, and we move that expression across the fraction bar, the sign of the power is going to change. So, for example, if I take this expression 2 to the -3, and I move it down into the denominator, the expression is going to change to 2 to the +3. Similarly, if I take this y to the -3 and I move it down into the denominator, this is going to change it to y to the +3. If I take this expression, x to the -6, move it up into the numerator, I can change the sign of my power so that I have x to the +6. Now everything is expressed in terms of positive powers. This makes the addition and simplification a little bit easier to handle. Since we have multiplication of like bases in the numerator, we can add together our powers to get x to the 6 plus 3. We know that 2 cubed is equal to 8. And finally, our two y's are like bases in the denominator, so we're going to get y to the 9 plus 3. And simplifying this, we get x to the power of 9 in the numerator, and 8 times y to the 12 in the denominator.